Hey guys, welcome back to a new video. In today's video, looking into some basic concepts of chemistry that will help you in the basics, or making the base of chemistry. Topic includes atomic radius. First of all, we're discussing about the atomic radius. Then we're going for the ionization energy, and then electron affinity, and then electronegativity. So, first of all, let's go for atomic radius. What is atomic radius? As the name indicates, like it is something atom radius. We want to find, like, this is an atom positive charge, this is an atom positive charge, and this is having a circular orbit, and we need to find this atomic radius, the radius of an atom. What we'll do, like, this very tiny particle. The thing is that, you know uh, as you know that we have gone through the advanced studies of the atom, and we got to know that this is this is kind of, you know this is kind of incorrect, this is not applicable. Why isn't? Let me discuss it further. Like, we have discussed that uh, orbit is in the wave nature. We have discussed it, and if we state the orbit is uh, it is in wave nature. Here is the positive nucleus, and we have not got any particular orbit. This called the wave nature of an orbit, and this was maybe de Broglie or Schrödinger gave it. And now this radius over here, like this radius over here and one over here, are not the same. Like, they are not the same. How will you calculate? Now the question arises, how will you calculate? What will you do? What we will do? Uh, you know, let me tell you a point. We will be taking a molecule. For suppose H2 molecule. H2 molecule. Now what will happen? Like, due to the molecular formation, the wave theory, or the wave nature of the atom stops. Like, when they come in a molecule form, this comes like this. Both are positive, and this is how we've got here. Sorry, that these are electrons. This one negative, this is second negative, and here are the protons, and here is the proton. Now, as wave nature is stopped, we can calculate the radius. And this is proved scientifically. Like, we have got a homo molecule, and the wave nature is stopped, and we did calculated the radius from here to here. This method is kind of applicable. This is applicable. Now, what if I do say, like, find me a radius of you know what would I say, carbon monoxide. Like, for suppose carbon monoxide, so what will you do? Like, will you applying like this? Like, if they're in wave molecule form, there would be no wave nature, but there would be carbon and oxygen. But uh, this is incorrect. This is not applicable over here. In the case of heteromolecule, it is not applicable. What's the reason? Let me tell you the point. Like, this is like, if this one was carbon, one was oxygen, this was suppose oxygen. Now, what the thing got happened is, the carbon is kind of a small atom as compared to oxygen. Like, oxygen is like this. Now, if you do, for this compound, the radius is kind of difficult to find, and we are unable to find radius over here to here because we have got differences. Like here the both were equal and we just found the divided by 2 the whole bond length. We divided the bond length by 2 and we found it. But over here it is not. It's different. This is not applicable. Now what this is the one thing you got is in the homomolecule we can simply take out the atomic radius simply by dividing the bond length by 2. And over here we've got difference. What we'll do, so far suppose this is C and oxygen, right? So let me draw this compound again, and this was carbon monoxide, right? Carbon monoxide, this is carbon monoxide, this is carbon, oxygen, and here here and here we are unable to find. Let me cut this because we are unable to find that. This is positive. We are unable to find the radius over here in this condition. This is carbon, oxygen, and this is carbon monoxide. Now what we will be doing is that first of all we will be taking carbon. We will taking carbon first. For suppose like if you got a atom molecule, take one of the element, and then for suppose if you're taking carbon, go for the carbon homomolecule. This is carbon, this is carbon, this is carbon, and then you will find the radius of carbon. I'm writing RC from here. From homomolecule it is quite simple. Now what we'll do is this is A and this is B and this is AB, right? And this is the bond length between them. Like we've got the bond length, we are unable to determine the radius, like where it divides. Like in the homomolecule it was equal cut, but here it's quite different. We've not got equal cut. Now we have, what we'll do is that we will be doing AB minus RC. What does it mean? Like we'll be taking out the radius of carbon in that atom. Now what would be the remaining one? Like this would be the one which would be left, and from here we'll be finding the radius of oxygen. This is oxygen radius. From here from homomolecule we found that. Now from we just minus this from here and just cut it, and this got happened. Now AP minus RC is equal to desired we can say over here oxygen radius in this case sorry, oxygen radius. This is how it works. I do hope that you learned something. If you did, do like the video. Meet you guys in the next video. Till that, goodbye.